Welcome to video lecture 2.6 Applications. We're going to talk about the strategy for problem solving. And there are quite a few steps, but if you follow the steps every single time, you should have a good strategy for problem solving. Occasionally you can combine steps if you feel very comfortable. So let's run through the 6 steps. The first step is read the problem and mentally list what you know and what you don't know. If it helps, you can write it down on paper what you know and what you don't know. Step 2, you want to assign a variable to the unknown items, and then you want to translate all the other information into the problem as an expression involving the variable. And we'll have some examples, so just hang tight. We're just running through the strategy. On step 3, we're going to reread the problem and then write the equation using the items and the variables we found in steps 1 and step 2 that describes the situation. Step 4, we're going to solve the equation we found in step 3. Step 5, we write our answer using a complete sentence. Okay, and we'll go through that a little bit more later in the lecture. And then 6, you once again want to reread the problem and then check if your solution with the original words of the problem does make sense, that it holds truth. Because our problems will be written problems, let's recall some of the vocabulary that we use to describe math terms. The sum of A and B is A plus B. The difference of A and B is A minus B. The difference of A from B is B minus A. The difference of A by B is A minus B. The product of A and B is A times B, or AB. The quotient of A and B is A over B, or A divided by B. Of means to multiply. Is equal. A number can be any variable. I'm just going to call it x. 4 more than x is x plus 4. 4 times x is 4x. And 4 less than x is x minus 4. So those are the basic ideas and concepts written, transferred over to math terminology. For example, the sum of twice a number and 3 is 7. Find the number. Now I'm going to run through each of the 6 steps. Once you get better practice at solving these, sometimes you can combine some of the steps. Step 1, reread the problem. We're going to list the items. The known items are the numbers 3 and 7. The unknown is the sum of a number. So the unknown is a number. We're going to assign a variable and translate the information. So I'm going to say let x be the number in the problem, what is unknown. Twice a number is 2x. The sum of twice a number, which is 2x, and 3 is 2x plus 3. Right? We're going to reread the problem. The sum of twice a number and 3 is 7. Find the number. We're going to write the equation. So the sum of a number and 3 is 7. Translate into 2x plus 3 equals 7. 4 we're going to solve. So 2x plus 3 equals 7. Subtract 3 from both sides. We get 2x equals 4. Divide by 2 for each side. X equals 2. Step 5. Write the answer in a complete sentence. So the number is 2. Why? Because the example was a written question, therefore your answer should be a written answer. And then reread the question. The sum of twice a number and 3 is 7. Find the number and check the solution. So the sum of twice 2 and 3 is 7, which is a true statement. Twice 2 is 4. 4 plus 3 is 7. Now, knowing each step does take practice, but if you run through them over and over and over again, it will kind of become second nature. First thing you do, read the problem. One number is 3 more than twice another. Their sum is 18. Find the numbers. So we want to know what the known numbers are. Well, we have 2 numbers and they add to 18. One number is 3 more than twice the other. So the unknown are the numbers in the problem. So we actually have 2 numbers that are unknown, but we know enough information to solve for those 2 numbers. So I'm going to let x and y be the unknowns. And just to keep them clear, y is going to be the larger number. So where it said 2 times the other, okay, the y is going to be the larger. So the first equation, 2 numbers add to 18. So x plus y equals 18. The second problem is 1 is 3 more than 2 times the other. So remember, I'm keeping y as my larger number. 2x plus 3 equals y. In essence, it didn't matter if these numbers were switched. We'd eventually solve for one and then find the other. To solve, I'm going to substitute what I know about y in 1 using the second equation. So x plus y, which y equals 2x plus 3, equals 18. Combine like terms, 3x plus 3 equals 18. Subtract 3 from both sides, so 3x equals 15. Divide by 3 to isolate x, so x is 5. Okay. But what is y? Y is going to be if x plus y equals 18 and x is 5 plus y equals 18, I'm going to subtract 5 from 18. Y must equal 13. So I know what x is and I know what y is. That's the end of part 1, 2.6. So until part 2, be seeing you.